Hello and good afternoon, students. So we were doing integration by parts, that is exercise 8.11. Today we'll start with question number 8 part 1. So in question number 8 part 1 we have integrate tan inverse x into dx. Tan inverse x into dx. Now I hope you can clearly see out here there is only one function given to us, tan inverse x into dx, and we don't have direct formula. So what we'll do but out here is I can write this tan inverse x as tan inverse x into 1. So hence now there is two functions. One is inverse, other one is algebraic. Now go back to the word ILATE. Inverse is going to be the first function, algebraic is going to be the second function. So now integrating by parts. This is u, this is v. Use the formula. U integration v dx minus integration differentiation of u into integration v and then dx integration by parts. Tan inverse x ddx of x1 integration dx1 minus integration, use a curly bracket, now differentiation of tan inverse x1 by 1 plus x square into integration dx is x, so therefore I am getting this step. Clear? Now here I cannot do integration directly, so what will I do is I'll assume this as I1, so hence I am keeping this as I1, where I1 is this. Simple. Okay, now what we know is in the previous exercise I have told you, if the power in the numerator is smaller than the power in the denominator, there were three things, right? One was power in the numerator greater than power in denominator. The second one was power in the numerator and denominator equal, and third one was power in the numerator smaller than the power in the denominator. Okay, so this is the third case. If the power in the numerator is smaller than the power in denominator, then we'll use substitution. If both the powers are equal, we'll make the numerator as denominator, and if the power is in the numerator is greater than the power in denominator, then we'll divide. Okay, so this is the third case then, right? The power in the numerator is smaller than the power in the denominator, so hence I'll have to substitute. So what will I substitute? P as 1 plus x square, then according to substitution I'll be getting this, right? So the value for x dx is dp by 2, and the value for this is p, so which will be easily solved, which is this part. You can clearly see dp by 2p, 1 by 2 constant, integration dp by p log p, put the value for p, so I1 is half log 1 plus x square plus c, so finally put the value for I1 out there, hence it is this expression. So this is the answer for question number 8 part 1. Question number 8 part 2, the question is integrate cos inverse 1 by x dx. Cos inverse 1 by x dx, a similar type of question, but we know the relation cos inverse 1 by x is equals to sec inverse x. So this is sec inverse x, and hence sec inverse x into 1. And this is your inverse function, this is your algebraic function. We know what to do. Okay, so pause the video, note it down. Alright, the next one I'm taking out here is this question, that is 9 part 1. We have integration x cube into tan inverse x. So again here also we can see there are two different functions. One is inverse trigonometric and the other one is algebraic function. So no doubt inverse trigonometric is going to be your u, this is going to be your v. So this step I hope you are clear. Integration of x cube is x to the power 4 by 4 minus integration differentiation of tan inverse x 1 by 1 plus x square, integration of x cube x to the power 4 by 4. So hence I get this step. Now I can see out here this integral, the power in the numerator is greater than the power in the denominator. Previous one it was smaller than the denominator. So if it is smaller, if the power in numerator is smaller than the power in denominator, substitution, and if it is greater, we have to divide, and if it is equal, make the numerator as denominator, right? So hence this is the power is greater, so we'll divide it. Okay, first let us assume this as I1. I1 is this. Here also I have written the power in the numerator is greater than the power in denominator, so hence we divide. So how will divide? We know how to divide it. This is my divisor, dividend, quotient and remainder, and we know that any fraction can be written as quotient plus remainder by divisor. So hence what do I get is this. If I divide, then I'll be getting this as quotient, remainder, divisor. Okay, minus sign, so within the bracket. Multiplied, plus and minus minus, so I get this. So therefore I1 was, if you see I1 was integration x to the power 4 by 1 plus x square dx, right? So the value for this is nothing but this, so I'm replacing this by this, and you open the brackets. When you open the brackets, it looks something like this. Integration x square dx minus integration x square by x square plus 1 dx. Okay, now no problem to integrate this x cubed by 3 throughout. It will be x cubed by 3. But the problem out here is I cannot integrate directly. Let us check the powers. X square, x square. So what do? The power in the numerator is equal to the power in the denominator. If this is the case, make the numerator as the denominator. So how will I do? I'll add plus 1, minus 1. Clear? Plus 1, minus 1. Pause the video and be clear with this. Power are equal. The powers are equal. So plus 1, minus 1. Put this in bracket. Again, use a curly bracket also out here because there's a minus sign. So when you separate and open the brackets, this will be the x cubed by 3 is as it is, minus integration this by this dx, minus into minus, plus integration 1 with this dx. Okay, this gets cancelled out, so only integration dx plus. Now this I can write in standard integral form, x square plus 1 square. You know which integral? 1 by x square plus a square. That was 1 by a tan inverse x by a. So x cubed by 3, this is the final answer. So put the value back in your I. This was this and this whole was I1, right? So this is the final answer. Please verify yourself, okay? Pause and note down. Alright, the next one I take out here is question number 12, part 2. The question is integration x cube sine x square dx. A similar example is also there in worked out example. Similar sum is also there in the example. So how will I do is you assume x square as p. Assume x square as p. Differentiate, you'll get the value for x dx, which will be dp by 2. Is it till here? Now come back to I. So we have x cube, right? So how I can break this as x square into x sine x square into x dx, because x square into x will be x cube. Okay, the reason I'm doing this is because I know x square is p, this is p, and x dx will be dp by 2. The whole integral will be in terms of p now. Okay, so which means this 1 by 2 constant, so integration p into sine p dp. Now this is easy for us, isn't it? You check which functions are there. P is algebraic function, sine p is trigonometric function, so no doubt p will be u, sine p will be v. Here is integration by parts. Just check the solution, very easy. Pause the video, note it down and verify yourself. It's alright, so this is your question. Okay, this is a continuation, so till here you know what to do, and finally put the value for p, verify yourself. Okay, the next one I have taken out here is question number 13, part 1, similar to number 12, part 2. The question is this: you also assume x square as p, you assume x square as p, and find the value for x dx. Now there is x cube. Write this x cube as x into x square. Okay, like this. Integration, substitution is done. Okay, so 2, this x cube I am writing it as x square into e to the power x square into x. X into x square will be x cube. Okay, the reason I am doing this is p, this is p, and this will be dp by 2. So all in all, which is this 1 by 2 gets cancelled out, by the way, 2 gets cancelled out, so hence I get p e to the power p dp. How many functions? 2 functions. P algebraic, e to the power p exponential, u v. This is your u, this is your v, and do your integration by parts. Okay, so that's it for today, and your assignments for today will be question number 8, part 2, similar one which I have done, 9, part 2, 13, part 2, and this 13, part 2 is same in example number 11, part 2 in your book. That's it for today. Do your works properly and regularly. Yesterday also I have told you in message. Okay, so that's it for today. I'll see you tomorrow.